I subscribe to your newsletters.
Oh, do you?
And I read
Very
them,
kind.
and I have been to your website recently as a journalist, and a science journalist in particular. I'm very interested in your work, and I'm delighted to have an opportunity to talk with you. I didn't recognize you because every time I see you, you're in a conference in a suit, and so
It's like dropping the suits, to be honest. Maybe it's California or something.
yeah. Thank you for being here and doing this kind of outreach, because as a journalist and as somebody who really wants to follow this information, I think you're doing a particularly good job at doing outreach and making the studies available to people. I see that the big piece of news this month, your paper, Human Brain Changes After First Psilocybin Use, was just published in Nature Communications. So that's it's huge that it's publicly available and that people can read it, and that people can really understand that you're looking at what happens to the brain, and recording the EEG during the experience, and observing the entropic brain effect, as you were saying earlier. And predicted improvements in well-being 1 month later is very interesting in terms of long-term effects, possibly, of psychedelics. So you notice that the key mediator of this, entropic brain effects, impacts the knowledge gap of what is present, right? You're providing critical new knowledge, correct?
I hope so, yeah. I mean, it feels to me that work filled a really key gap, a knowledge gap, which is, one side you have people focusing on the pharmacology, say, the low-level stuff, or maybe they focus on something like the growth of new synapses, for simplicity, like parts of neurons. So is that all you need to have a therapeutic effect? Is that the secret source of how psychedelics work, that they grow these synaptic components, these branching bits of neurons? Is that all you need to do to get, an improvement in depression or an improvement in well-being? Or at another extreme, you have people saying you need a mystical type experience. You need to meet God or become a believer, and realize that there is meaning in life, and so on. And so it's this a very rich, profound, but also very difficult to describe human experience. And these worlds are very far apart, growing branchy bits of neurons to meeting God. I mean, what's the stuff in the middle? And I'd like to think that this study put some, shed some light on the stuff in the middle. And so we see brain activity becoming more, there's more to it. There's more going on. That's the entropic brain effect. It's hard to say in the next moment what brain activity will do, because it's very unpredictable now. It's very complex. That's the entropic brain effect. We see it rise up and peak at the intensity of a psilocybin trip, and then it comes down as people come down. And we also see that the bigger that entropic brain effect, brain activity becoming richer, relates to psychological insight, which we measure with a rating scale, subjective rating scale, people saying things like, or rating items that say, I have had fresh insight into my life or my past or my relationships. So classic kind of psychotherapy stuff. Classic psychedelic stuff as well, meaning psychedelics seeing the psyche, seeing more of the psyche, the whole of the mind than ordinarily you do. So it's saying that this quality of brain activity change under the psychedelic relates to this quality of experience. And then those things together are predicting the improvements in mental health downstream. So it's starting, I think, to demystify and fill that space in the middle, which is sort of saying, is this magic? Well, it's magic on a poetic sense, in a poetic sense, certainly feels magical, but there's also some biology to it, and so maybe it can demystify in that sense.
Let's talk about the biology for a second. I'd like to ask you about Alex Kwan's data showing that psilocybin changes blood flow. Does that challenge any premise that signal reliability correlates to neural activity?
Alex is a fantastic scientist, and I think he's been doing some mouse neuroscience. And I'm not sure of that particular finding, but he has found some brain circuit changes. And one of the issues that we have now is joining the dots between what's found in a mouse brain under a psychedelic and what's found in a human brain, and also how that relates to human experience, something that we can't address with mouse behavior. They can't tell us what they're feeling. So yeah, there are things you can do with mouse neuroscience that are more invasive, that can tell us things that we can't do in humans, because we can't ethically have that level of invasiveness. And so I would like to think of it as a sort of, like a team with different skill sets, ideally working together. It's not always that way. And I think Alex was a commentator on our paper, and it was quite positive, his comments in terms of this moving the needle in terms of our understanding of things. We all think we've got the best methods, but I think things work best if we work together and borrow each other's methods.
Indeed. How do you work with other scientists? You were doing another paper coming out about plasticity, for example, and you've announced that on your site as well. And you're arguing that neuroscience and mental health research have become a little sloppy in how they use the term plasticity.
Yeah.
Could you comment on that a little bit?
Yeah. So I guess we all learn some bad habits and we get stuck in our ways, and I think neuroscience has done that. And so what do I mean there? We have brain markers, examples of brain changes that we'll call plasticity. But those changes aren't necessarily associated with plasticity in its most basic sense, and also in the sense that's most validly relevant to psychedelic action, whether that's the trip itself or the therapeutic potential. Plasticity in its most basic sense means changeability. And when we use it, intuitively, we're really saying psychedelics make us more changeable. It's a psychological observation, psychological intuition and observation. And we've known for a long time, I would say, we could keep adding evidence to it, and better quality evidence, that psychedelics promote plasticity in this psychological sense. But I think the neuroscience world wants to put a biological marker on it, but I don't think they've necessarily done a good job of doing that. And so they'll find brain changes and they'll call it plasticity. They might call it neuroplasticity, and they should. They might be even more precise and call it anatomical neuroplasticity. It might be the growth of the branchy bits. They might call it synaptogenesis, they're right to. But they might be a bit sloppy and call it plasticity, when it's not necessarily. Because we don't know yet whether it happens in the human brain. That's never been shown properly. And we don't know whether it relates to the plasticity that we refer to when we say psychedelics promote plasticity, that they make people more changeable. It may well be that certain brain changes anatomical brain changes, say neuronal changes, actually relate to lower plasticity than higher. There might be things that happen, there might be changes in the brain that happen through the acquisition of bad habits, like becoming addicted to a drug of abuse, like cocaine or amphetamine or an opiate. Brain's going to change. We might measure it as neuroplasticity, and yet the individual, whether it's an animal or a human animal, is actually less plastic now. It's become, its behavior and way of being in the world has actually become less plastic. It's stuck in a rut, and it's doing the same thing over and over. It's drawn to a particular drug. So that's the sort of paradox here. Is like, it's sort of basic principles things. First principles is like, psychedelics promote the psychological plasticity. So what in the brain, I'm not saying that what happens in the brain isn't important, I'm just saying, have we really thought carefully enough about what the brain effects would be to map to that basic psychological plasticity? And what I say is that there's probably a mediational plasticity. I think it might be the entropic brain effect as a good candidate for that. And there might also be a longer lasting brain change that relates to the healthy changes, getting out of the rut that we were stuck in, being more flexible now, being more open-minded now, being more optimistic now. And so what's that? I call that recalibrative plasticity. It's like a reset. And these are brain changes, I think, that might not necessarily be consistent with the neuroplasticity effects that neuroscience have done a lot of work studying. So it's a lot of the work that I feel I'm doing these days is like tidying up a bit and addressing some wrong assumptions and being more, trying to encourage us all to be a bit more precise and clear in our understanding of things.
Great. Thank you so much. I appreciate it. 2 more quick questions. And I'll follow up with you via email.
Sure.
The UCSF Global Psychedelics Study, this large-scale online survey study to enhance safety, awareness, and well-being of psychedelic users. There's an existing global psychedelic survey that's been going on since 2023, and it's a big international collaboration. Why is this new Canopy survey needed in addition to that one? And the second question, how will it benefit people using psychedelics in a non-clinical sense?
Yeah. Well, we've been doing real-world data collection now for about a decade. And what it's called, I guess, is maybe an irrelevance. So some years ago, we had a global psychedelic survey. We didn't do a big sort of splash on its name, but its value, real-world data collection, is very complementary to what can be done in a lab, because in a lab you control a bunch of variables, but then that limits what you can know and address. You don't have a rich array of contexts in which drugs were used, or you don't have a rich array of drugs that were used because you dialed it in on one that you're testing. So it gives you all that diversity, all that richness. It also gives you very big data sets, because you can collect data from thousands of people, which we've done over time, over the last decade or so. And so this one's already up to, last time I checked, which was about a week ago, 300. And so the data just comes flooding in. And we've got a few different versions, a version that respects people's time. We call it breezy in-house, but brief and easy, so it's a light lift for people. And then we've got a longer form for people who want to geek out and do all those extra surveys. And we'll get more information that way. It's just, people have to give more time for us to do that. Then we have a version with brain imaging we call Bay Area brains for local people. They can come in and have an MR scan before and after. They can go away with a little EEG device to potentially record the entropic brain effect while they're tripping, wherever they choose to do that. So there's this kind of hybrid approach that we use, sort of citizen science approach, where people sign up to, doing some gonzo science off their own back kind of thing, and in collaboration with us. It makes them feel more part of the scientific process. So there's a lot of extra value to what you can do in a lab. It's very complementary in that sense. Yeah.
Thank you so much. I greatly appreciate your time today. What haven't I asked you that you think is important for people to know about your research and for our community?
Well, there's the first study we did at UCSF. I've been at UCSF for 5 years now. It was a deep sampling brain imaging study using fMRI, using EEG. And I asked the ethics committee, can we be the guinea pigs? Very Shulgin-esque. It was, I wanted to bring it up. It's like, no, the honest thing to do here, because we're going to give psilocybin 4 times, and all the tripping is going to happen in a scanner. So it just feels right that if, we're going to ask other people to do it, we do it ourselves. And they said no. And I've always questioned that. I think they got it wrong scientifically and ethically. I think there's a compelling ethical argument for gonzo science, being your own guinea pig. I think there's also a scientific argument because you're just close to the material. You just have a depth of understanding that otherwise it's hard to get. You become the subject rather than the observer, and I think there is scientific value in doing that. You learn more. So kudos to the Shulgins for doing that, being pioneers of that.
Thank you so much. This has been a lovely conversation. Yeah. Thank you, Megan, for inviting me to ask some additional questions. And thank you for making your work so accessible to others. Yes.
Thank you the same.
Yeah, absolutely. Fully in the spirit of, I think, the research that's been done here.
Yeah,
yes.
Lovely full circle.
Indeed. Great.